Welcome to section 9.3, hyperbolas. We're going to go ahead and look at the formula for the hyperbolas and then identify how to find all the parts. Let's get started. To begin with, we have the shape of our hyperbola. We can see the blue portion on this top and the bottom represents our hyperbola. For our hyperbola, there are several things we need to be able to find. We can find our two focus points, we can find our vertices, and then we also have our asymptotes we'll be able to find, and these are all based off of your center. Let's go ahead and look at the equation for these things. For our first standard form, we have x minus h squared over a squared minus y minus k squared over b squared equals 1. The important thing when looking at hyperbolas is identifying which variable is positive. In this case, because x is our first variable, we can see it's positive, whereas we will have a negative y variable. As a result, we know that our hyperbola is actually going to open up left and right. So it's going to be a horizontal hyperbola. Our center, as normal, is going to be h and k. Since it is opening up left and right, to find your major vertices, we have h plus or minus a, comma k. And for your minor vertices, we have h, comma k plus or minus b. For your focus points, we have h plus or minus c, comma k, where this time c is going to equal a squared plus b squared under the square root. For our second form, notice that now our y variable is what is going to be positive. So we have y minus k squared over a squared minus x minus h squared over b squared. Our center is again going to be h and k. Since your y variable is the positive variable, we're going to have a hyperbola that opens up and down, which means for your major vertices, we're going to have h comma k plus or minus a. For your minor vertices, we'll have h plus or minus b comma k. And then using the same equation for c, we'll find our focus points as h comma k plus or minus c. We also have asymptotes that we need to be able to graph to form our hyperbolas. So if x is our positive variable, then your asymptotes are going to be y is equal to k plus or minus b over a times x minus h. If instead y is your positive variable, then you're going to have y is equal to k plus or minus a over b. So the key thing here in determining which equation you use for your asymptotes is which variable is positive. For our example here, we're going to go ahead and find the center of the vertices, the foci, and the asymptotes for the equation y squared over 1 minus x squared over 4 is equal to 1. Two important things to note here. We have our y variable is positive. Also, that helps us identify where our a and our b values are. A is going to be under your y variable, whereas b is going to be under your x variable. So we can very quickly identify a and b from our equation. Again, notice a was under our y squared variable, so we have the square root of 1 is a, whereas b is the square root of 4. And then using our equation of the square root of a squared plus b squared, we can find our c value. Now that I have my a, b, and c values, I can also identify my vertex. And since we have just a y squared and an x squared, our center is going to be the point 0, 0. Okay, taking my a, b, and c values and also my h and k values, I can plug them into the following equations to fill out for the rest of my pieces, which means for my major vertices, we're going to have the point 0, 1 and 0, negative 1. For my minor vertices, we're going to have the point 2, 0 and negative 2, 0. For my focus points, we'll have 0, comma, plus or minus radical 5. And then finally, for my asymptotes, we'll have y is equal to plus or minus 1/2 times x. For our next example, we have a small change here. We can see that our x value is the positive variable. So that's going to help us identify things when we want to find our center, vertices, foci, and asymptotes. Since x is our positive variable, that means the number under x is going to be our a value, and then the number under y is going to be our b value. So we take the square root of 144 to get our a value of 12, and then we take the square root of 25 to get our b value of 5. And then using our equation to find c, we get that at 13. Looking at our equation, I can pull my center from our equation. So I should have a negative 3 and then a positive 2 as my center. And then I can use those values to help me fill out the rest of my equation. So for my major vertex, we're going to have 9, comma 2 and negative 15, comma 2. For our minor vertex, we'll have the 2 points negative 3, 7 and negative 3, negative 3. For your focus points, we'll have 10, 2, negative 16, 2. And then for our asymptotes, we're going to have y is equal to 2 plus or minus 5 over 12 times x plus 3. We're going to go the opposite direction now, giving you information such as the vertices, the foci, and the center. We're going to use that to help us find the standard form. The first thing I wanted to point out here is I'm using these specific equations based off of my information. So I know for my vertices, my x value is what is changing. So that tells me to use this following equation to help me identify my a value. And a is going to be the distance that my vertice is away from my center. Since we're going out a distance of 2 in either direction, that means my a value is going to have to be 2. For my focus point, again, because my x value is what is changing, I know this is the equation I'll be using to help me identify my c value. And using a similar process, c is going to be the distance the focus is away from your center. So since we're going out 5 on either side, that means my c value is going to be 5. So I now know a is 2 and c is 5. I can use my equation for c to help me identify what my b value is going to be. And since c is equal to the square root of a squared plus b squared, I again plug in my information, and now it helped me identify what my b has to be. So I get that b ends up being the square root of 21. Now that I know a and b, I can go ahead and plug in the information to find my equation in standard form. Again, it's very important to note that my x value is what was changing, and that helped me identify my a value. So I know that my x value is what's going to be the positive portion of my hyperbola. So now all I need to do is plug in a and b into my equation. And then if I simplify my a and my b values, I end up getting the final equation of x squared over 4 minus y squared over 21 is equal to 1. For our next example, we're going to do the same thing. Given the vertices and the foci, we like to identify our standard form. The first thing we like to do is figure out what formula it's going to be using. So I can see that for my vertices, my y value is what is changing, which means I'll be using the following equation to help me identify my a value. And then for my focus points, I can also see that my y value is changing. So I'll be using this formula to help me find my c value. In order to find a and c, I do need to find my center. And to find my center, I'm going to be finding the midpoint of my vertices and also the midpoint of my foci. And that midpoint should end up being the same point which will represent the center. So by finding the midpoint of my vertices, I get the point 4, 5. And it is the same midpoint if I found it using my foci. And again, to find the midpoint, I'm basically just averaging my values. So I have 4 plus 4 over 2, and then 1 plus 9 over 2 to find my y value. Same thing for the focus points. Again, 4 plus 4 over 2, and then 0 plus 10 over 2. And both times I get 4, 5 as my center. Now I can go ahead and identify my a value by figuring out how far away 9 is from 5. And that's actually a distance of 4, which tells me my a value is going to be 4. For my focus points, I'll do the same thing. I want to figure out how far away 10 is from 5, and that has a distance of 5, which means that c is going to end up being 5. I can now use a and c to help me identify b. Using our formula that c is equal to the square root of a squared plus b squared, I can plug in my a and my c values, and then as I simplify, I end up getting that b is equal to 3. Now that we know what a and b are, we can go ahead and find our equation. We also want to make sure we remember that our center was the point 4, 5. So I'm going to plug everything into my following formula, and I get y minus 5 squared over 4 squared minus x minus 4 squared over 3 squared is equal to 1. And I want to point out that I knew that y had to be positive because I used the equation where y was changing to find my a value. I'm going to go ahead and simplify the following equation. I get my final hyperbola of y minus 5 squared over 16 minus x minus 4 squared over 9 is equal to 1. For the following example, we'd like to write it in standard form. And for this particular example, the only thing we really need to focus on is making our equation equal 1. So in order to do that, I'm going to divide both sides by 6. And then I'll go ahead and simplify what I have. I have x squared over 3 minus y squared over 2 is equal to 1. Now that I have my equation in standard form, I could identify my parts, and I could use that to help me graph it. For our equation here, we want to go ahead and write this one in standard form as well. We have a little more work to do here, though. My first step is to go ahead and pair together my x's and my y's. So I have 9y squared plus 54y. And then we have negative x squared plus 2x. I'm going to go ahead and move the 62 to the other side, so I have equals negative 62. I'm now going to go ahead and factor things out so that I have a coefficient of 1 in front of my y squared and my x squared. So I'm going to factor out a 9, and that leaves me with y squared plus 6y. And I'm going to leave a space because I'm going to end up completing the square. And then I'm going to factor out a negative 1 for my x's, so I have a negative 1 there, which leaves me with a positive x squared minus 2x. Again, we're going to be completing the square, so leave a space there, and equals negative 62. When I complete the square, I'm going to end up taking half of my middle term and squaring it. So half of 6 is 3, and then 3 squared is going to be 9. So we get y squared plus 6y plus 9. And then same thing, I'm going to take half of negative 2, which is negative 1, and square that, so I get a positive 1. And then on my right side, I do have that negative 62, but I have to balance my equation. So since I'm adding a 9 times 9 on the left side, that's going to be the same as adding 81. So I'll put plus 81. And then I also have a negative 1 times a negative 1, so I'm subtracting 1. So I'll go ahead and subtract 1 as well. What I can do now is I can simplify this expression by factoring it. Same thing with my x values, I can factor that, and then I can clean up these three terms together as well. So what I end up getting is 9 times y plus 3 squared minus x minus 1 squared is going to equal 18. And then for my final step, I'd like to divide everything by 18 because I need this to equal 1. So when I end up doing that, I get y plus 3 squared over 2 minus x minus 1 squared over 18 is equal to 1, and I have my final equation in standard form. All right, guys, that does it for the notes for this section. Go ahead and get started on the homework, and good luck.